This is the 4.4 Day 1 notes. We started talking about parallel and perpendicular lines. We've talked briefly about this before, but this is when we're actually starting to prove lines parallel and perpendicular using their slopes. So parallel lines are going to have the same slope and different y-intercepts. Now on our notes, I had this graph with 3 different lines, and a lot of you, when you first looked at them, you said, oh, those are parallel. But we went ahead and actually calculated our slope because lines can appear to be parallel when they're actually not. So I'm going to encourage you to always calculate your slope to determine whether or not they're parallel. So the first thing that we did, since we do have lines, they gave us points so we could use the slope formula, but it's easier just to use the slope triangle whenever you have a graph. So notice that all these lines slope down, so I know the slopes are going to be negative. So for line A, if you start on the first point, you fall 1, so that'd be -1, and then you run all the way over to there. That is, if I'm counting, 1, 2, 3, 4, 5. So that gives me a slope of -1/5 for line A. For line B, you fall 1, so we still have that -1 on top. And when you run on this one, you run 1, 2, 3, 4. So that has a -1/4 slope. For line C, you fall 1, so once again we have that -1 in our numerator, and we run, let's count that, 1, 2, 3, 4, 5. So we have -1/5. So what you should notice is that line A has a -1/5 slope and line C has a -1/5 slope. So we would write that. We would say line A is parallel to line C. If they asked you for the proof, you could just show where you calculated the slopes. Parallel lines have the same slope, and notice they have different y-intercepts. These cross the y-axis at different points. For this second example, they've given us some information and they're asking us to write an equation. So it says write an equation of the line that passes through 5, -4 and is parallel to the line y = 2x + 3. So what they've done here is they've given you a point. So they've given me an x1, y1, and then they've also given me a slope kind of indirectly. So you're supposed to know that parallel lines have the same slope. So if I'm trying to write the equation of a line that's parallel to the given line, they need to have the same slope. The slope of that line is 2. So if you have a point and you have slope, you should be using point-slope form. So we have y minus y1, which in this case is -4, so that becomes +4, equals your slope, which is 2, times x minus x1, which in this case is 5. So what I'm going to do now is I'm going to go ahead and write this in slope-intercept form, which means I need to distribute my 2. So I would have y plus 4 equals 2x minus 10. And then I'm going to move that 4 to the other side by subtracting. And when I do that, I am going to wind up with y equals 2x minus 14. Now just to make sure that it follows the definition of parallel lines, I notice that these lines have the same slope. See, they both have 2 where m is, and they have different y-intercepts. B in this case is 3, and over here it's -14. Therefore, I know these lines are parallel. For this last example, they are telling me that we have line A, which passes through -5, 3, and -6, -1. And we have line B, which passes through 3, -2, and 2, -7. And they're asking if the lines are parallel. So since parallel lines have the same slope, which I've given you as a hint over here on this left side, and they've given me 2 points that fall on each of those lines, I'm going to need to calculate the slope using slope formula. So the first thing I'm going to do is label my point x1, y1, and then I have x2, y2 for line A. So I'm going to calculate the slope by doing y2, which is -1, minus y1, which is 3, over x2, which is -6, minus x1, which happens to be -5, so it becomes +5. So all I'm doing is using that slope formula. So -1 minus 3 is -4, and -6 plus 5 is -1, and -4 over -1 makes +4. Okay, so that's line A. That's the slope of line A. Now I need to find the slope of line B. So once again, I'm going to go ahead and label x1, y1, and x2, y2. Now I can use my formula, which is y2 minus y1. Notice y2 was -7 and y2 was -7 and y1 was -2. That's what made that +2. And then I have x2 minus x1. So -7 plus 2 is -5, and 2 minus 3 is -1, and -5 over -1 is +5 for the slope of line B. These lines are not parallel because they have different slopes. So, if you're given a graph, then you're going to calculate your slope using the slope triangle. If you're given points, then you're going to calculate your slope using the slope formula. And that formula is on your formula chart. You do not have to memorize it. Just make sure that you are doing y2 minus y1 and x2 minus x1. Okay? That change in y needs to go on top, and that change in x needs to go on bottom. Okay, so that takes care of day 1. We focused on parallel lines, and on day 2 we will focus on perpendicular lines. You guys have a great evening.